morning. Today, we will prove the 6 trigonometric differentiation formulas. We will use these two limits for the first formula. By the definition of derivative, here is a sum of two numbers, so use the sum rule. Sine of x plus h equals sine x cosine h plus cosine x sine h. So you can realize everything that you have learned is important. Nothing is unimportant. You have to familiar with everything you have learned. Okay, here we mean that x is given. The variable is h. The variable is h. So when the x is given, sine x is a real number, a coefficient of this one. Cosine x is also a real number, a coefficient of this one, real number. In order to use that, these two limits, this number times cosine h minus 1 over h plus cosine x times sine h over h. So this difference quotient can be expressed by a linear combination of these two expressions. Now we use the two limits just reviewed. And we use the limit theorem. This limit is 0. This limit is 1. This proves the derivative of sine x is cosine x. So, if you know the derivative or the speed of sine x is 0 and the cosine x is 0, then sine is a wave. The slope of any position x is a linear combination of these two slopes. Similarly, is the limit of the difference quotient. Again, use the sum formula. This is cosine h minus sine x sine h. Again, this difference quotient is also a linear combination of this expression and this expression. Since the limits of this one and this one exists by limit theorem, this is cosine x times this limit is 0. This limit is 1. So this one is also derived. So there are many rules in the nature. The graph of sine function Now we consider the slope function of sine. At the 0, the slope is 1. At half pi, the slope is 0. 0. At pi, the slope is minus 1. Minus 1. Then here is 0. Here is 1. Here is 0. The slope is 0. Slope is minus 1. Okay. When x increases from 0 to half pi, the slope from 1 increases to 0. When x from half pi to pi, the slope is from 0 decreases to minus 1, negative of 1. And 3 pi over 2. From minus 1 increase to 0. So the slope of sine looks like this. It seems that this curve is cosine, and our proof shows this is true. The derivative of sine is cosine. The derivative of sine is cosine. So the red curve is exactly cosine x. Okay. Similarly, you can consider the slope function of cosine. Here is 0. Here's minus 1. Exactly minus sine. Minus sine. So if we learn things step by step and not in a hurry and review everything, you can keep then everything will come clear. Okay, the third formula, the derivative of tangent is secant squared. Secant squared. This time we use differentiation formula. Use the quotient rule. Tangent can be expressed by the quotient of sine x and the cosine. Now use quotient rule, cosine squared. Differentiate the numerator, we obtain cosine. And keep the denominator minus, keep numerator, differentiate the denominator, the derivative of cosine is minus sine. So here, what we use is this. We use this differentiation formula. Okay, since this sum of the square of cosine and sine is 1. And then by the reciprocal property, this is secant squared. Okay, next. The derivative cotangent. Cotangent is the quotient of cosine and sine. We use this differentiation formula again. The square of denominator. Differentiate the first one, obtain minus sine, times denominator minus, keep this one, times the derivative of sine is cosine. Again, use the Pythagorean identity. This is 1. And then by the reciprocal property of trigonometric functions, this is exactly cosecant squared.